Okay, Mr. Hunt here with constructions for segments inside triangles. I'm going to start with just doing 1A, and then 1B is what you're going to do. It's just another practice to do on your own with a different triangle. For each of these, we're going to draw the in circle, which is a circle that fits perfectly inside a triangle. Okay, so it doesn't like go past here. It touches each side once. Here's how you do it. To make an in circle, from each angle, there's 3 angles. I'll go ahead and label A, B, and C. You just make an angle bisector from each angle. So the in circle is formed by 3 angle bisectors, and then we'll be able to draw it in. Okay, so basically, a lot of these in this section you kind of just do on your own. We've done angle bisector before. You just got to do it 3 times. All right, so I'm going to do a lot of work here. Might not be fully on the camera here, but so I'm going to do an angle bisector starting at A. All right, and you can do again, just do all 3. So then I go from here and I make an arc out in the middle. I do the same thing over here. I draw it in. Try and be pretty precise, very accurate with these, because then you'll get, what we're going to find is there's going to be a point where these lines all meet. That's where we'll draw in our in circle from. Okay, so I'm going to go over here to C. Make an arc. The other thing with these, you got to be careful, they'll start to overlap. See, so you just got to be very careful and see, all right, where is my line? Where's my point? It's like right there. Remember too, sometimes I've had this question: where do you connect there with where? It's with C. That's what you were bisecting C. Okay, now the intersection of those 2 lines. So right there. Oh, sorry. The intersection of those 2 lines right there is really where we should go from. But I encourage you to still do B, because you might have been off with one of these 2 lines, and so B should verify it should go directly through. Okay, so I'm going to do B here. Move this a little bit. Actually, I think on mine I got slightly off with B, but you can see they all 3 meet right here. Again, the more precise you do it, the better it's going to be overall. So then to make your in circle, you start at this point where all 3 lines meet. Take your compass, set it on that point, and you take your pencil and put it perpendicular, straight down to one of your 3 sides of the triangle. Okay, and the better move this a little bit. So it's right there, and again, the more accurate you are, the better. It'll turn out. Let's see. So I have my compass from there down to AC. Let's see. So now I'm just going to make a circle. Let's see how I did. Well, it turned out pretty good. So again, I just had my compass set. Compass at the center, pencil over here, and then I drew a circle. And you can see mine, I mean, right there it might have gone slightly outside, but overall it worked out pretty well. And this is actually reflects I'm looking at the bottom of this theorem, actually reflects a theorem from our triangles unit that these are, this point, let's see, the incenter is equidistant from each side. And that was a theorem with angle bisectors. We actually proved it in our triangles unit. Okay, moving along. Okay, so number 2, draw the circumcircle. Circum, like navigate, circum means to go around. So this time the circle will be around the triangle. And this one's pretty simple. It's similar to the last one, 3, but this time perpendicular bisectors. So you start at each angle. I'll just set A, B, and C. Do a perpendicular bisector. I'm sorry, you don't start at each angle. You start at each side. Excuse me. For perpendicular bisector, we're at the sides. All right, so I'll talk through one and then I'll quickly go through the others. Might be off screen a little bit. So AC. I'm looking at AC. Perpendicular bisector, I'm at compass on C, more than halfway. I do full semicircle. Same thing, go over here to A. And then you just connect those. Oop. Okay, and then you'll have to repeat for AB and BC. So I'm going to do those again. It might be not fully on camera here, but I'm putting my compass on A. Put my compass on A, more than halfway. Semicircle. B, same thing. Connect these two, so you can kind of see right there. So get on screen. Right here, oh no, where these two lines meet, right there. That looks like that should be our point we start with. I'd like for us to go ahead and do BC, just to verify. So again, compass on B, making a semicircle, compass on C, I'm more than halfway, semicircle. So you get these three. When you do these, it's kind of easy for me to see when I grade these. It's like I see these like sets of semicircles, I see 3 of them. And then I look at the overall circle. And look at that, that one's pretty darn good. They seem to all go through right there. Okay, so to draw the circle, the circumcircle, the circle that goes around the triangle but goes through the 3 endpoints. Compass on that point, and the pencil to one of these 3 vertices. I'll just go from A. Let's see if I got it pretty good. So then, just draw the circle. Okay, and there you go. It looks pretty good. My compass, my circle went through A, B, and C and hit them pretty much exactly. See, so looking at the bottom, that we actually did this theorem, you know, this in the triangles unit, it says the circumcenter, which is this point, the intersection point to form that. Yes, you don't need to know that name, but that point is equidistant from the 3 vertices A, B, and C.